So before we, all right, thanks. So before we call this to order, I need to read the following. Pursuant to Chapter 20 of the Acts of 2021, an act relative to extending certain COVID-19 measures adopted during the state of emergency, signed into law on June 16th, 2021. This meeting will be conducted via remote participation. No in-person attendance by members of the public will be permitted. All right, so that said, I'd like to call to order the meeting of the Sustainability Subcommittee of the Neary Building Committee of the Town of Southborough. It's Friday, June 14th, 2024, and it is 10:10 a.m. The subcommittee has all its members in attendance. So first order of business, I'm going to go a little bit out of order, presuming that this is sort of going to be the part of the other business. Mark, presuming that you and Chris both got the minutes in your packet,
Did.
I'd like to see if we could approve those minutes. So I would entertain a motion to, well, finally, I'll make a motion to approve the minutes. And let's see which they are. The minutes of the Neary Building Committee Sustainability Subcommittee, Wednesday, June 5th, 2024, that met at 1 p.m. Is there a second?
I'll second that.
Okay, seconded by Chris. Roll call vote. Mark?
Aye.
Chris?
Aye.
I vote aye, so that passes. And I think we will now go back to the I think we'll turn it over to the architects. We're going to go back to talk about HVAC, correct?
Great. Yep. I'm going to share my screen, so if somebody can enable that.
All set, Kate. Should be popping up soon.
Yep, it came up. You can see the screen with the agenda on it.
Yes,
You can still see that, right?
yes.
Okay, great. So yes, we're going to talk about HVAC system options today. So for a school building, there are really four system options. It's really three. There's one variation that are all electric system options. You might ask, why is there no gas system option in here? I'm not sure if that's a question you have, but I'll answer it anyways. So in the new energy code, you won't be explicitly precluded for being able to do a gas system. It's potentially possible to do a gas boiler system, but the pricing for that gas boiler system is going to be pretty much equivalent to the least expensive of these options, which is a VRF system. And it won't be applicable for any incentives, whether that's state incentives like the Mass Save program. It won't be applicable. You won't be able to get any Mass Save for the whole project. And you can't get federal incentives either. We will talk about incentives today at the end after we go over the system options. And so, that being not the lowest cost construction wise or lowest cost after incentives, it's actually one of the most expensive systems now. Plus the fact that once you're in operations, because it is a gas boiler system, you'll be dependent on the utility and utility costs and fluctuation, as opposed to if it was a all electric building, you potentially can have solar either on site or through some other process that can help you sort of stabilize and have predictable costs of utilities. And so we typically don't recommend gas systems for school buildings at this time. So the four systems that we typically look at for a school building are options 1 and 2, which are ground source systems. Ground source I'm assuming you're all familiar with ground source, but essentially it's closed loop wells that go down into the ground. They're not transferring water with the ground. But those wells use the ground and the temperature in the ground as a heat transfer. So whether you're doing heating season or cooling season, you have that fairly stable ground temperature, which helps improve your efficiency. And the ground source systems are the most efficient systems because of that. The really difference between option 1 and 2 is option 1 is a ground source heat pump chiller heating plant. And basically that's distributing both hot water and chilled water through the building. And so you can achieve full cooling, which is essentially a 75-degree set point, where option 2 is using a heat pump hot water generator. So it's for generating hot water. And then the ground loop is not producing chilled water. So the ground loop is going to air handlers and helping to produce dehumidified cooled air. But the set point there would be 78 degrees. So it's not what we call full cooling. And that's the main difference between 1 and 2. Why you might do 2 versus 1, I would say the majority of projects are option 1 that are doing ground source. Option 2 is a little bit less expensive. But again, you don't get that full cooling. We all know that over time, temperatures are continuing to increase, especially in the swing seasons when schools are in sessions. And during the summer, schools are often used as well. And we'll go more detail of these as just sort of an overview. Those 2 systems, as I mentioned, are the lowest energy systems, the most energy efficient. And so those are net zero systems. And again, we're defining net zero as an EY of 25, which is a benchmark that is established through the Mass Save program, as well as other national benchmarks for schools. Option 3 is a VRF system, essentially is an air source heat pump that's using the air as the heat transfer instead of the ground. The air temperature obviously has wide fluctuations from very cold to very warm, so it's not quite as efficient, but heat pumps in general are quite efficient. And that's why it says maybe net zero, because this sometimes really can't get quite to the 25. It might end up being like 26, 27. And so that's why it says maybe net zero. And to really determine whether it could be a net zero would really rely on every unique building and doing an energy model of that building. And then option 4 is an air to water heat pump chiller heating plant. Essentially, that is using a heat pump chiller to produce chilled water, and it also has a backup, or not a backup, a supplemental electric boiler. So this is the least efficient of all these systems. It's in the high 20s to 30 EUI. It's not a net zero system, but it is potentially more traditional in terms of people who might be used to a boiler chiller kind of situation in a building. This is just an electric boiler instead of gas. And looks like, Chris, you have a question.
Yeah, so option 4.
Yeah, so Chris, good quick question or quick comment. I'm going to suspend the hand raise kind of thing because really with just you and Mark.
Yeah.
So,
That's fine.
Ask anything you want, okay, at any time.
Yeah, I just didn't want to interrupt anybody. So option 4, are your credits lowered just because of the use of an electric boiler? Because you would be talking just an air cooled chiller, right?
Yeah.
Or are you
And so-
talking a centrifugal?
No, it's a heat pump chiller.
Yeah.
So it's still, that part of it is quite efficient. The electric boiler is the very inefficient side of that. And that's why the EUI tends to be higher.
What about a cooling tower with a water cooled centrifugal? How does that weigh in?
Again, that would be on the chiller side. So that would probably be similar, maybe a little bit less efficient. But again, you're generating heating through for a school, it still is predominantly heating load dominated. And so the electric boiler is getting quite a bit of use.
Yeah, so I've seen a couple recent projects where obviously the boilers are secondary, that you're injecting heat into the loop on those really cold days. So Roger, Mark, a heat pump system loses its efficiency when it gets cold outside, obviously, because the ambient air temperature is so low that some of the systems are derated in 0 degree weather and below. Most systems can go up to -14, but, and some are even getting more than that, but you do lose your efficiency on the heating side, so you have to supplement with electric heat. I know you talked about cost, and electric boilers. I've seen just the required electric consumption on those. I've looked at a couple of projects where we need to almost bring in a whole new service, so that electric boiler would only be supplemental. I take it, just to increase
Right.
the temperature.
It would be supplemental, yes.
Okay, and there's like, cause I still have projects that are looking at that and getting gas approved as a backup to the heat pump system. Because gas still is efficient, especially when you put a high efficient condensing boiler in, and you're at 97% efficient.
Yeah, so for the new Mass Save program that will go into effect in 2025, you can't have gas as any supplemental or backup.
But that's just for the rebate purposes, right?
Yeah,
From
right,
September.
that's for the incentive side of it.
In the center side of it, yeah.
Yeah, and it all done, it kind of depends on the location. Some projects, even if there is gas on the site, you cannot get a new hookup, even though it's not maybe a new gas service. Most of the utilities won't allow you to use gas in your building if it's not the prime source of heating.
Mhm. So option one obviously is gonna be our most expensive, because we would have to put a well field out and drill wells.
Yeah, and I think we'll probably answer some of your questions. Maybe I can just move a
Yep,
little bit
keep
forward
going
and
on
we'll,
the
and we'll
slide,
get
yep.
to that piece. So those are kind of the overview, and you notice at the bottom, it talks about the ventilation distribution for each system. And options 1, 2, and 4 can work with a displacement ventilation system, and option 3 does not work with the displacement system, so it would have to be a overhead mixing system. And so, and I don't know if everyone is familiar with displacement, so I'll just go over that a little bit. So people are most probably familiar with traditional mixing ventilation systems where you're supplying overhead at the ceiling. You're also returning, usually on the other side of the room, at the ceiling level, and you're relying on higher velocity of air to come down and mix to provide the ventilation in the space. Displacement ventilation is supplying air low on the wall in the occupied zone and the breathing zone, and so it can be supplied at a lower velocity. And so instead of mixing, it's coming in where you need the ventilation in the breathing zone, and then it's exhausting up high, similar to a traditional mixing system. The exhaust is up high, and basically that allows you to, the temperature of the air sort of stratifies and allows the air quality. Well, both the systems will be high air quality because we'll be doing filtration systems. Potentially, we won't talk about this today, but potentially CO2 demand control ventilation. And so the air quality will be good, but it is better in the displacement system just because of the fact that it's not mixing in the space. It's really supplying low and returning high. There are some improved acoustics and thermal comfort because you're supplying that air down low. You don't have to supply it at as high a velocity because you're not trying to mix the system. It's really relying on the buoyancy of the temperature in this space. And so it's lots of times we've had people who walk through the building and say, I don't even know if this is on, but it's on. It's just not you don't hear that whoosh of air. And then it provides more thermal comfort. Because of that, you're not getting drafts from that system like you might have in an overhead system, and reduced energy. So that system is more efficient from the ventilation system in terms of how it's supplied. Any questions about?
You wouldn't, the displacement system, how would, what would be your method to get the air down low? You wouldn't be talking raised flooring or anything, right?
No, it's supplied on the wall. So you can see in this diagram here. So there's a couple different ways that we do it. Sometimes it's a recess in the drywall. So it's just, you'll see the flat grill, which is usually like a 2 foot by 4 foot sort of perforated metal looking grill.
Yep.
There are also products like what's kind of in this diagram where you, from Price and from others, it's like a product that kind of sits not flush with the wall. It kind of attaches to the wall. And so they make these prefabricated half rounds and different things.
Yep.
We typically put them like where the teaching wall is, because lots of times at lower grades, you would have like maybe rugs there. As you go up in other grades, people aren't typically sitting right in front of the teaching wall. And so that's a good place to put them, because there's not, you can't put furniture. That's one thing you don't want. You want to make sure people aren't putting furniture in front of this. And so that's usually where we put them in classrooms. There would still be some spaces that wouldn't have displacement, say like offices and admin areas. Those would have overhead.
So Kate, I'm wondering, and maybe this might be later in your presentation, the four options, do each of the four options qualify for the 4% reimbursement from the Mass School Building Authority under their 2023?
Yep. So
Okay.
the specialized code compliance that gets you the 3%, that it just has to be an all electric system. So all of these systems would qualify for that. And then the 1% for the IIQ credits aren't really impacted by this, because that relies more on the filtration media and things like that, which would be the same for all systems.
Okay, thank you.
Kate, with the, just on the air side, before you move on, sailings, would they be, would you have a full ducted return, or would it be open plenum?
So it would be ducted return. With any of the systems, the return would be ducted.
Okay.
And the reason why we talk about this is because there are options with like the ground source system, and even option 4, you can do either overhead or displacement.
Yep.
It's just the VRS system is using fan coils. And so you can't use a displacement with that.
Correct. Yep.
So this is a little bit, actually, I'm going to come back to this. Oops. I'm just going to run through these just so we understand exactly like what the basic equipment is. So we can run through this quickly, but ask questions if you have them. So with the ground source system, you have indoor equipment for the heat pump chiller heating plant. That's indoor equipment that's going to the ground wells. You'll have, on all the options, you'll have air handling units on the roof. And you'll, again, for displacement, this is all showing displacement with the ground source. Displacement, you'd have that low in the room. You'd also have radiant cooling and heating panels at the perimeter with this system. First, option 2 is going to look very similar, except for you won't see the radiant cooling panels at the perimeter. You will have some supplemental radiant heating at the perimeter, but the displacement, the ventilation system, regardless of what type it is, the ventilation system is doing the bulk of your cooling and dehumidification for the space, because you don't have chilled water, you won't have the radiant cooling. The VRF system is going to be all rooftop equipment. Your air handlers, you also have outdoor units for the VRF, and then you'd have fan coils in the ceiling. So this is going to have active fan coils, not just, supply grills. And so you have fan coils with motors and filtration and other components that do need to be maintained. And that's probably the biggest difference between this and the ground source systems, is you have a lot more equipment, active equipment, that needs to be maintained throughout the building. And then option 4, it's similar, it's mostly rooftop equipment. And then the electric boiler would be inside the mechanical space. For this, you have radiant panels. Again, this can achieve full cooling, and so you have radiant panels at the perimeter. I think I can't remember if I mentioned this on the VRF system. GGD typically recommends an electric radiant at the perimeter. And that is just in case the system goes down and the fan coils can't be used, you really have no source of heat in the space.
I don't know if you can answer this question, but in any of these options, are the floor to ceiling heights, can that be reduced in one option versus over another in terms of looking at savings just in what's above the ceiling?
They would all be typical. They don't have to be sloped. We're showing them sloped here, which is really just to get daylight into the space and to have more ductwork in the usually some sort of entry space into a classroom. They can be certainly be flat ceilings. And the floor to floor height is typically the same with all of the systems.
Okay, the slope system is nice. The slope ceiling is nice in terms of bringing light deep into the classroom. So that really wasn't the issue. It was really about any opportunities for economy of savings if we, for example, you could take a foot out all the way through the building. That would save some money in terms of construction costs, but it doesn't sound like there's any real difference between any of the options.
No, I mean, it's mostly driven by the ductwork, and that's very similar size between all of the systems. The ductwork does get smaller for the displacement system as it goes to the wall grills, but the mains are somewhat similar.
Okay, along Mary Ann's line of thinking, does that also play true for common areas whether they're like rotunda entryways or cafeterias, libraries, gyms? Would the same kind of theory apply, that we couldn't really get any gains if we did reduce the ceiling height in some of those spaces?
Yeah, those larger multi-story, potentially 1.5, 2-story spaces are really governed by the height requirements. So the gym's going to be the height that it needs to be, so you're not hitting a ball on the beam all the time.
Yeah.
Same with cafeteria. So the space and volume for that is really driven by the use needs. The mechanical system, the HVAC system, isn't really driving the height for that particular system.
Okay, thank you.
I talked about 4. Okay, I'm gonna go back. So these are just some high level pros and cons. We've talked about some of them already. On the ground source heat pump side, it is the most efficient system. So we have the lowest EUI, lowest energy used. It's also the lowest operational cost on the utility side in terms of not needing as much energy, but also on the operation and maintenance side, compared to say like the VRF system, which has a lot more equipment and things that need to be maintained throughout the building. It will be the lowest first cost after incentives, and we'll talk about the incentives. And it has full cooling. You obviously need a well-filled area, and so that is a consideration. Option 2, that is very similar, except for it doesn't have the full cooling. And then the VRF system, it doesn't. The main advantage there is there's no well field required for that. It will be the lowest first cost before any incentives. It can maintain full cooling. It may not get to net zero, so that's really the biggest con. More outdoor equipment, not that roof space will potentially is taking away roof space if you want to have photovoltaics on your roof. It's more that it also is a lot more equipment. So each VRF system is going to handle, maybe a wing per one floor of a wing of a classroom bar. So you're going to have more rooftop equipment to maintain. And then on the air to water heat pump, chiller, boiler, it's least efficient. So it'll obviously have the highest utility cost, and it can't get to the net zero. Which has the biggest implication there is utility costs, but also the incentives.
So on that line, are you also seeing with projects now, are they just setting themselves up to be solar ready for the photovoltaic, or are you seeing municipalities putting that into their construction projects right from the beginning?
So we're seeing both. I would say every building, I mean, it's required now by code, every building has to be net zero ready if it's under five stories or less. But in terms of putting them in, I think the majority of our projects going through MSBA have been putting them in day one.
Okay.
Even going back to our Hillsborough project, which opened in 2021, Larry will probably remember, that didn't get to full net zero, but they did put that system on.
When you
And
say
it's a mix of ownership and PPAs, probably more PPAs than ownership.
when you say PV ready, so like you allocate the roof space, you incorporate your structural for the supports for the panels, run the conduit for the electrical, right?
Yep.
Had-
Reserve the breakers and the space in the
Spacing.
panels.
Okay. Yeah, you almost go to a percentage and it's like you're almost there. You might as well just benefit the points, get the energy and if one question I have, terminal equipment. So with all these options, the school really will not have a piping infrastructure. So based on those sketches, I'm guessing you're doing terminal equipment. Now you showed supplemental electric heat on the wall space, you know, you showed radiant panels and then a backup heater. Are those the radiant panels hydronic or electric?
So the radiant panels are hydronic in the ground source system and
Okay.
they're electric in the VRF system.
So,
And so you will have piping, you'll have, chilled and hot water piping going from your heat pump chillers, to your air handling units. You're also going to have chilled and hot water going to your radiant
So-
perimeter.
are you planning on doing that as a dual temperature or 4 pipes? Or you for simultaneous heating? Cooling?
It'll be 4 pipe.
Okay, so Mark and Roger, one thing to consider with this system, you're putting the infrastructure in. Say at the end of the day, we had equipment failures, or we all of a sudden we're going back to gas because the grid can't keep up and the energy companies start raising their electric rates and everything else. You're putting the infrastructure in that you could support a traditional heating, cooling system if you ever had to convert it. Where a VRF, you're gonna have a network of refrigeration piping running through the building. VRF's becoming common, but there's a lot of changes with refrigerant type. Gases are changing. Their refrigerants are going to a flammable gas. I don't know if you guys are facing any of those challenges with running refrigeration and fire rating and 2-hour ratings now.
Yes, the new code, it is
Yeah.
technically, you can use it and it goes into effect. You can only use it after January 1st. Does still have a miscommunication between that IBC and I think it's the mechanical code.
Yeah, we don't have.
The industry is hoping to change that, but right now you would have to run those in the shafts, the rated shafts. Even though there is the further IACC past 2021, I think it's 2024, that does fix that, but we're stuck with the 2021 because that's what we just adopted. So right now we have to assume that they would have to be in the rated shafts.
So like the biggest thing with VRF is like Kate said, a lot of equipment, a lot of maintenance. You have a refrigerant leak in the system. It's, you're to go and find a refrigerant leak. It's not like water where you bleed through the insulation. You could have a technician out there troubleshooting a unit for hours, just trying to find and they use sniffers and whatnot, but if there ever was a failure too, that refrigeration does leak out into the space. And I've always questioned it with the VRF systems, just like a chiller has refrigeration and it's in a contained room, but ideally we put them in schools all the time. But I ask myself, why isn't there a refrigerant monitor, a leak detection device with a VRF system? Because essentially, if you have even a large condenser with, up to 100,000 BTUs of cooling capacity, what if you have one leak in a classroom, that refrigeration just dumps out in the classroom? I've always asked the question, and I know there's criteria about square footage and makeup air and what is required, but if you ever have a leak, that refrigeration's dumping in that classroom for the whole system. And that's what I always concerned about, like I see it spec'd on jobs, we're putting it in school, so even though I do put a lot of the VRF systems in, I think a system that has some infrastructure with, piping, you're already gonna do the ductwork no matter what. You have to bring ventilation and fresh air to the room and classrooms and spaces. So I think, our best option would be to look at a system that has piping infrastructure, especially if you're doing water source on the terminal boxes as well. Are you reheating the air with VAVs with hot water coils? Be electric, because you're running the
I
distribution.
think so, but
Radiant panels, right?
GGD would need to confirm that.
Okay. Because that makes sense. You're already bringing the pipe into the classroom for the radiant panels. You can do the VAVs with the hot water reheat as well.
I'm like 99% sure that it is, but
Yeah.
they could answer that.
So Kate, could you go back to the summary of four diagrams?
This one,
No, yeah,
no,
so,
the pros,
no, you had it.
The first one, yeah.
So which one of these is closest to what you just described, Chris?
Well, obvious, one is great because it has cooling, and I think you need cooling nowadays. Like, I was in Woodward for an end of the year thing a couple weeks back for my daughter. The school was, it was hot. I was like, how are you guys roasting here all day? And it's,
There's no question that we're gonna,
yeah.
be moving to cooling for sure.
Yeah, I mean,
You're absolutely right.
You could do option two with, and Kate, you can jump in, but you could have the ground source. The difference is you're using a heat recovery chiller, right?
right. The main
Versus-
difference is option 2 doesn't have a chilled water line. And so it'll be conditioned air, it'll be dehumidified, but the set point is going to be 78.
Couldn't you add
So-
like an air source heat pump on the ground or on the roof to option two? Air source chiller, excuse me.
You could, but at that point, you're kind of just going back to option. The reason why option 2 is on here is because
It'd
we
be
had one
option 4, yeah.
specific client who was like, I don't want chilled water in my building, which
Yeah.
is not typically the case. And so we, tried to come up with this alternate solution that removed the chilled water component. We ended up finding the cost was not that different. And you lose the full 75-degree set point.
But you're saying, Kate, that option 2 is rare, it's rare that you've seen? That doesn't necessarily mean it would work for us, but I mean, what are you saying about?
Yeah,
option-
we have one building that we're designing this for.
And how many buildings that you're designing option 1 for?
We have 2 that are in service that are already been open for a while
Okay,
on schools, other non-school projects, but for schools.
all right, I'm sorry about derailing this and.
No,
you're
it's
supposed
fine. I
to-
think no matter what with option 1 and 2, we're gonna pay the premium for the geothermal.
Right, so, let me just go through, so this was the pros and cons. This is essentially what you will get in the life cycle cost assessment, but right now we don't have specific numbers, so it's just kind of giving you a preview of how the different systems stack up against each other. And so this is really just showing you like the qualitative. We will in schematic design do this as a quantitative process, and essentially 3 systems will be studied in that. So right now we're talking about 4. Ideally, we narrow it down to 3 that will be done in the LCA. And in the PSR phase, we're looking for like, what's the preferred option right now, just for cost perspective, because we typically don't cost out multiple options at this phase, but in SD, we'll do estimates for 3 systems. We'll do the modeling and LCCA for 3 systems. But this is just a preview that kind of shows you what we already talked about in terms of the net zero potential. This actually shouldn't have a check mark on there. I apologize. The EUIs, kind of how they stack up. CO2 emissions is really just directly related to that. The less energy use, the lower emissions. We talked about the air quality and the thermal comfort, which is mainly the air quality is derived through the displacement ventilation, thermal comfort. Variation in there is, this is full cooling and displacement. And the VRF, doesn't have the displacement. Acoustics, we talked about that again, is related to the displacement and why there's a differentiation there, as well as the VRF, doesn't have displacement, which is quieter in terms of supplying air, and it also has active fan coils. So the fan coils and the motors in them are also adding additional sound to the space. So it's the ventilation being overhead and the fan coil that is why that acoustics is less for that system. Metering is essentially the same. The energy cost is really associated to the energy use. The annual maintenance cost, this is really why VRF is scoring low against the others. We talked about this already. Additional equipment, all the fan coils and the ceiling spaces, additional rooftop units, outdoor units. And the capital investment cost, you can see this is without the incentives in this first column and with the incentives in the second column. And essentially it kind of flips, and the ground source then become the least expensive options once you look at the incentives. And the life cycle savings, this is mostly derived from the energy reduction for the ground source systems, means less utilities, less equipment to maintain versus the VRF system. And so that's what's factored into that.
Kate, how does this chart relate to whether it's a new option versus a renovation option?
You could assume it's essentially the same. Because they're both, when it's a renovation option, the biggest cost implications are ductwork. Ductwork is the same between all of them. You're running refrigerant lines for VRF versus potentially piping lines for the ground source. So it should be fairly similar in terms of all the other metrics are the same. And the construction cost would only be the one that might fluctuate a little bit, but it should be the same as this in terms of, and I apologize that I can't remember exactly what the distribution system is in the existing Neary building.
It's probably just heat ventilators. I think that age of
Unit ventilators.
perimeter heat, H&V units for makeup air. That's pretty much it. Most like typical school.
Is there a sense about what size the well field would need to be if we proceeded with geothermal? Has there been any kind of thermal conductivity?
Actually, it's a couple. Yeah, so we don't have thermal conductivity, but we looked at both. Katie, there's two enrollments, right? 310 and 610. I was going to say that, and I was like, maybe I have that wrong. It's 310 and 610. So the 310, and so the lower enrollment, we think would be somewhere around like 40 wells, and the higher enrollment will be about double the number of wells. That's anticipating, fairly shallow wells, I guess we would call them, but like 500 foot deep. And so if they were deeper wells, it's less wells, but.
You said what, 1,000 foot wells, right?
500 foot.
500.
Wells.
Let me drill down, because I'm a proponent of reading in advance the dummy for heating and cooling systems. If you're talking 60, and let me just really go back to basic science, how these things work. We've got a looped pipe that's going from our equipment down into the ground and then back up to our receiving equipment.
Mhm.
In the summer, we're pumping warmer water down, and in that 500-foot loop, it's going to be chilled to a certain extent to the groundwater. And we're
To the
bringing,
ground temperature. It's not necessarily the
Right,
groundwater,
right.
because it might not be in water. Rock or,
if you're
in the
going
ground.
500 feet down, you won't be in water. You'll be in a harder substance. But we're coming back up with chilled water. And on the heating side, you're taking cooler water down, and it's coming up at a much more moderate temperature,
Mhm.
and then being electronically heated to the level that we get it to where we're comfortable in the classroom. Is that right?
Right. And you're not actually heating. So a heat pump doesn't actually heat like the way that a gas boiler would.
Yep.
It's combusting, or an electric resistance heater. It's actually just heat transfer. So the heat pump is essentially compressing and decompressing to create heat and transfer heat.
Now, why so many wells? What dictates
The tonnage requirement of the building.
Yeah, so the well tonnage is gonna be between 1 and 2 tons per well
Okay.
at like the 500 foot. And so this is just based on, multiple other projects we've done. If you decide to do the ground source system, they'll actually do a desktop review and figure out, okay, what projects have been done more locally. They'll look at the geology, they'll look at the borings, they'll make a guess. And then at some point, you do the test well, which means you do 1 or 2 wells that can be used in the real building, once you get to full construction, but those to just double check the thermal conductivity that you're receiving on site.
So essentially the well's just serving as a conduit for the pipe going down and the pipe coming back up.
Right. Where the air source heat pump is relying on your air instead of your rock and earth as your heat transfer.
Okay. I'll have more dummy
Dummy.
questions. My only concern is when we get to the stage of bringing this to the committee as a whole, we may want to need to go through that explanation. Just so people understand the impacts. So, and then let me take it one step further. The geothermal project that is Eversource is doing over in Framingham.
Mhm.
It's not just for one customer, it's going to be for 80 customers.
It's a
Yes,
district-wide system.
Are there wells being intermittently run through the system? And they're doing individual loops? How does that?
That
reach
one,
from what we're doing
that
here?
project, I believe, had 3 well fields with 3 different pumping stations. So,
Okay,
but they did put the infrastructure in the street on public property, which, because it was for mostly city of Framingham buildings. So
Yeah,
that.
and they're testing actually, I think 3 different types of wells as well.
Yeah. Yeah,
So
there were
why
3
couldn't,
different field locations.
why couldn't we deal with a low number of wells? Is it just?
So that's the number of like those are estimates, but it'll be roughly in that ballpark based on the
Okay.
square footages. And that's just gonna serve the heating and cooling load for the building.
Okay,
So like rule of thumb, Mark, is if you have 1 ton of cooling, it's probably a 500-foot well. Am I correct in saying that, Kate?
Yeah, we typically estimate that the well will be between 1 and 2. 2 is on the high side. Usually we don't get quite to 2. It's usually between 1 and 1.5 tons per well.
So if you have 50 tons of cooling.
now,
And as a perspective of what that looks like, 40 wells would be roughly a site space of like 40 by 100 feet. At 500-foot wells, they get spaced on a grid that's like 20 feet on center. It doesn't have to be an exact grid. You don't have to have a rectangle of space, but that's how far that part they are spaced.
so the cost of this is entirely borne by us? Or is Eversource doing any grant money?
Yeah, so that is a good segue into, and I know we have like 8 minutes left, so I just want to jump into incentives. And we'll talk about what the incentives are for each of the systems, because it varies depending on the technology.
Let me ask the final question and then you can answer it in this section. Wellesley had an issue when they did this, that they weren't a gas customer. And there was a big to-do over there on that they couldn't get the incentives because they no longer were bringing gas in. And my understanding is they physically had to bring a gas line in to qualify for all the incentives not to use gas. Has that been rectified?
I'm not familiar with that particular project, but the incentives are available whether you're a gas or electric, and it's run by your electric. So if you were in a location where your electric is say Eversource and your gas is National Grid, electric governs there, and so Eversource would be your provider that goes through your incentive program.
Okay, so in this, okay, so
and you don't need to have gas on your site today to qualify. If you were trying to get incentives from gas, obviously you would need gas, but they don't any longer incentivize any gas systems.
So the guiding utility is the electric side.
Right.
Oh, so, okay, it'll be National Grid. Okay.
So there's really three sources. We talked about MSBA last time, so I'm not going to talk about that today. On the federal side, there's the new investment tax credit, which is available for direct pay, and I'll talk about that in a second. And the national or the federal incentives are about technologies. So it doesn't care about your energy use or your E or Y. It's if you have solar, you can get this much for solar, you can get this much for ground source heat pumps. On the state side, it's Mass Save, and there's path 1 or path 2. Path 1 is the net zero path. It's that 20, they care about the EUI, not the technology. And so 25 EUI is what governs path 1. And if you're over 25, you're not eligible for path 1. So you would be in path 2. Just a little bit about that section 48 ITC. Basically you go through construction, you place the system in service, and then after construction and place in service, you fill out a pre-registration application, and then you essentially file a tax return. You know, you're probably not following them today. It would be a specific form for the direct pay, you know, by whatever tax deadline is in that year. I assumed it would be 2029. And then you would get your reimbursement payment for direct pay.
And what are the figures you're seeing on those incentives? I've heard a few customers recently almost to, you know, almost received up to $1 million for a geothermal system, if not more.
Yep. So I think that's 2 more slides. We'll get there one second. So just quickly, you don't have to pay too much attention to this chart, but for the section 48, each technology is applicable for different percentages of costs that are covered. We assumed that you would do prevailing wages and apprenticeship program. And so you would be in the 30% as your base, like that's the lowest it can go. If you weren't doing the apprenticeship and prevailing wage, 6% is where you start. So we assume we'd start at 3. And then there are particular bonuses that you can get, whether it's a low income community. There's a domestic content, meaning the content is produced in the United States, and energy community bonuses. The only bonus that it would be applicable to this project and its location and its census tract is the domestic content. And so domestic content is easier to get on the ground source equipment side, less easy to get because we don't produce a lot of solar panels in the United States. And so that's why it says solar would be between 30 and 40. We're just going to assume 30 for now on the next chart. And then 40% is what we're assuming for the ground source. The project is not applicable. This is on here because this is just a reference chart. So you understand that there is another credit for refueling, alternative refueling, that's EV charging, but it's not in a census tract. That this site is not in that census tract, and so it's not applicable. These percentages are reduced and adjusted for tax exempt bonds. So if you're doing tax exempt bonds, a 30% would actually end up being 25.5%, and 40% would be a 34%. So just want to make sure you're aware of that, so you understand when we look at this chart why you see 35 and or 25.5 and 34 as opposed to 30 and 40. So on the left-hand side, you have ground source heat pumps. On the right, you have air source heat pumps. This is for the 350 enrollment. And so for the ground source heat pumps, this is a loose estimation based on the square footage and how many wells we would need. And this is not just the well field. This is all of the equipment. Almost 100% of the HVAC equipment can be covered because it's all connected and supplied through the ground source system. So this is like your total HVAC cost. And the estimated incentive at a 34% rate. On the chart, I also put in solar. It just says solar and wind because both of those qualify. I assume this would be solar. And so I just did an estimate of if you wanted to do 100% of your energy use generated on site, that's just what that budget number is. And you can see an estimated value. And then on the Mass Save path 1, because this is a ground source, it would be eligible for path 1. That is just over $1 million for the incentive for that. The incentive for path 1 includes incentives or cost per square foot for getting to that EUI of 25, and all the path programs. So 1 and 2 in Mass Save, they have heat pump adders. And so whether it's a VRF system, an air source heat pump, or a ground source heat pump, you get a certain amount per ton. The VRF, I think, is $450 per ton, and the ground source is 4,500 per ton. And so that is a huge difference. They're extremely incentivizing the ground source system on the Mass Save program. And then it's also heavily incentivized for the federal program. So looking at just, and I put EV charging on the bottom, this is obviously, we don't know how many EV charging spaces you'd end up with, and that's, not a huge percentage of the cost, but I did just add that in so you could see that. So the potential incentive on the ground source would be 4.7 or almost 4.8 million. And on the left, I'm just showing you the total construction costs of all of this. And then if you subtract the incentive, the total construction cost is 6.6. On the air source side, it's the same number for solar. And I just assumed it was the same, even though the EUI might be a little bit different, but to just simplify that, I put it the same. And then the air source heat pump system, I estimated at about 7.2 million for that HVAC system, but you can't get any incentive from the ITC because it's not ground source. They only incentivize ground source, air source, and BRF does not get incentivized. So that's why that's 0. Path 2 is most likely the path for the air source heat pumps. Potentially it might get to the path 1, that 25 or less, but for this, I assumed it was at path 2. Path 2, the cost or the incentive reimbursement per square foot is much lower than path 1. And so the majority of this number is coming from the heat pump adder for the BRF. And so you can just see the total construction and the total construction after the incentive. I will say that I didn't run this through with a path 1 option. Like if the VRF could actually get to the EUI of 25 and do the path 1, I can certainly show you that. It will still be a lot more than the ground source. You would get, I think it was like 300,000 more on the incentive side of it. So it'd be just under 8 million.
Yeah, so next week we're starting drilling for geothermal out at Neshoba Regional High School. So I don't know if folks would be interested in seeing that or not, or if you're already familiar with it. The issue with the apprenticeship training that relates to the drillers, because this would be a prevailing wage project, which is because it's a public project, but we would want to make sure we could secure a driller for the geothermal wells that was also signatory. And that's where you need to have a certified people who are participating in certified apprenticeship programs. So that would include for electric, plumbing, HVAC, I believe, and the driller.
Yep. And that gets tracked through the subcontractors, and the CM also tracks that for the whole job.
And I would just like to say for the tax incentive program too, there is the provision, I want to say it's either Buy America or Buy American. So it's, the tax incentive, it's very complicated. And I just, like Mary Ann mentioned, the apprenticeship program. And then also we have that, the Buy America requirement also. So just something as we're going through this, we think about that too.
Because it would need to show up in the documents, what the expectations are in the bid documents.
I would assume that 90% of the contractors that are going to be looking at this are either going to be signatory or set up on with DCAM, because they have to be bonded and approved for this size project. Even some of the sub scope of work, I mean, you're looking at a $20 million mechanical package, all said and done, I'm guessing.
Yes. I'm just pointing out that some of it might be difficult to find a driller, for example.
Got it. That is DCAM certified, that pays the prevailing wage if they're not signatory.
Right, so the issue specifically really, in my mind, is about the apprenticeship training program there, because this will be a prevailing wage project.
Correct, yep.
Right. The good news is that there are projects that are already starting to go through that, and So you'll have some time before you'll be going to bid, and hopefully the industry is all kind of aligned with that.
Couldn't you cover that? The geothermal that's going on in Framingham, the contractor's RH White. RH White is a non-union contractor, but when they get involved in these, they will pay the prevailing wage. I assume the driller in that particular contract is a subcontractor of RH White, and then they're bound by all of those same wage issues. So
Yeah, so it's not really
It's
the
just-
prevailing wage. That is
What-
common practice. It's just the apprenticeship program is different than apprenticeship programs that subcontractors and contractors are already doing in Massachusetts. It's a federal guideline for that, and it is a little bit different. And so it can be done, but you just have to be very clear that you're requiring that. And that everyone knows that joining the job, because it is going to be a little bit different. So if you're already doing apprenticeship, it might still be a little bit different in terms of the tracking and what you're doing.
okay.
Marianne, do they fall under civil, or are they something different? I know like Skillins and Sons are contractor, not to go down this hole today, but like what division do they fall under?
Well, if you have the drillers, I'm gonna say sandhogs, for lack of a better
Yep.
term. And if you have laborers, I'm sorry, and if you have laborers, then they're not necessarily skilled labor for drillers. So we are finding sometimes there's gaps there.
Hmm.
And I'm just putting it out there that that's something to be mindful of
Yeah,
going forward.
So that is all I have. This is just showing the 610 enrollment. The numbers just proportionally increase based on the increase in the square footage.
All right. I'm not exactly clear on what we're gonna be taking to the full committee, but
So what we're looking for this phase, for the PSR phase, when we get to the estimating portion of it, is to know what system you would like priced as the preferred system. And then we'll be doing all the analysis of multiple systems in SD and picking the actual final system in SD.
yeah, so when is that? In other words, you're looking for what the preferred system is, and when do you need that? Are we just about, are we close to that?
I believe it's mid-July that we're sending sorry, I'm just gonna pull up the schedule, for when we're sending the PSR. Give me 1 second. Here we go.
are we doing cost estimates on multiple systems?
We're sending our information to the estimator on July 19th. So we would need to know sometime during that week. We have an NBC to choose a preferred option for PSR on Monday, the 15th. I think it would likely be part of that conversation so that everybody in the committee knows what decision had been made.
July 15th.
July 15th. I'm sorry, did I say
Right.
June? July 15th.
Yeah, and Chris, just to say, usually at this stage, we try to identify a base system,
Yeah,
and then we can have some pricing alternates if the committee is wanting to compare A to B, but more detailed research and pricing is typically in schematic design.
yeah, I would go with, in this phase, if I think you look at the geothermal, Roger, Mark, I just look at the geothermal, it's gonna be the most expensive, and then when we gotta make cuts, you pretty much, those other systems are very, very similar, you add in the well, you add in the well piece to it, you could take off. You could very easily back into the air source, and if we wanted to look at another option, I would recommend looking at VRF. Someone may ask, hey, what is, what could this cost look like if we really had to make cuts? The other systems are so similar to the geothermal, it's pretty easy for us to back into some ROMs, some rough order magnitudes of what those systems would be if we had to. You guys
So-
agree?
I'm sorry. Who did I interrupt?
No, that's fine. Go ahead, Roger, I'm done.
Well, so are we talking about, so, are we talking about one or two, or really at this point, one is kind of the geothermal choice?
They need something for a baseline for the
Right,
SD set and,
Yeah, I
Weigh
mean,
in.
one would be on the first cost without incentive, that would be the most expensive. So, conservatively, if you did that, the estimate, that would be sort of the maximum cost.
But it's what a lot of people are leaning towards now. I'm old school. If I could have a 4-pipe building, chill water, fan coil, gas boilers with a cooling tower, I'd say put that in, but I don't think we can do that with all the requirements right now. And if I were to do anything, I'd lean towards the geothermal. But we can have some future discussions with the engineer record. I would like to see, in the piping arrangement and set up down the road that there are future Ts left off in case, we're talking exterior equipment, right? That chiller you're doing, is that gonna be outside or you're gonna put it inside with remote condensers?
The heat pump chiller,
Yeah.
that will be inside.
You're gonna do inside? Okay.
Yeah.
Seeing a couple different ones going outside and it just, scares me with New England weather.
Yeah.
And being it, sole source of heat, I just think we need to talk about that backup heat in case of an emergency. Whether you have, ground issues, you never know. I just think we need to have that conversation.
Yeah, so oftentimes that system will have an electric boiler that is truly
Backup.
sort of emergency backup.
Yeah. And there's no way
That's
to,
part of the code, Katie?
It's not required by code to have that
Not
now.
required to have a backup even for municipal buildings of, even if they are I'm thinking of a shelter space or if they've been deemed for the emergency type stuff.
shelter in
Yeah,
place.
so that's different. If it was a shelter, then you would need to have heating or cooling on the generator,
generator.
which would be different than this backup boiler.
But
Okay,
yeah, this will be on a generator, right? Your heat it should be on a generator for school.
So typically we would have like freeze protection heating potentially on the generator, but not for occupying the building.
Okay.
Trottier right now has that, Chris, at the percentages it needs. So Trottier at present is the shelter.
Gotcha.
So I don't believe Neary would need to have that. I think it exceeds our capacity needs with what's been determined based on my understanding.
Mm-hmm. Okay. Yeah, I mean, I think geothermal is the way to go, and then if we have to pare down after that, we can look at other options.
So it sounds like we're coming out of here with option one, right? Or
Yep.
Chris nodding, Mark nodding, I'm agreeing.
I just gave a thumbs up. I don't have a vote, Roger, but I gave it a thumbs
I
up.
saw the thumbs up.
Okay, other things we should be doing today, folks, Kate or anyone? Or
Nope.
are we good to go to the next step?
We're good to go to the next step. And I think the last thing we talked about from last week is just on the next full building committee meeting was just your recommendation to do lead as the path and to do the 1% and 3% for a total of 4% green program for MSBA. And I don't know that the system selection as the preferred just for the PSR phases needs to be confirmed, but those would be the three kind of decisions that came out of last week and this week.
Okay, now Chris also mentioned that maybe that our backup option would be what, option 3 there? Is that, Chris, what you said with?
Well, I think option 2 with no no cooling is, I say you take that off the table.
Right.
And if you really have to pare down and you want to put a system in that has infrastructure, you go to option 4.
Oh,
And
option 4, okay.
option 4, and then I think if you want to look at a VRF option, if really we're talking costs,
Yep.
then we can move to VRF option. I think VRF's great. I think it has its applications. Doing a whole school, he did a project that had 75,000 feet of refrigeration pipe on it, and it was just a mess. And I think, you know, having an infrastructure with piping, it's not refrigeration piping. If you ever had to convert it later, you have that infrastructure in place, and I don't know, VRF's everywhere, being used everywhere, but I mean, we could take a look at it if you know, money is part of the discussion and we really gotta make some cuts.
All right,
If I just throw in, just remember that the 4% affects the $100 million project or whatever the project's going to be. So that's a real significant number coming back to us. Has really nothing to do with the cost of the heating side. So we may be classifying this as a costly item, but the reimbursement effects of that 4% are huge.
And the
So-
savings, the, you know, operational savings throughout the years are gonna be.
Yeah, I think
fair
there's,
point.
I
Both fair.
don't like to attach the most expensive term to this, because I think everyone on the building committee recognizes that there's 4% hanging out there that has a significant impact on the project as a whole.
Agreed.
So I just want to point that out.
You know, it'd be definitely worth, you know, to say they built a new school and it's, you know, what are we trying to achieve here? You know, we're trying to make it most efficient, reduce the carbon footprint, meet all the sustainability goals.
And make it maintainable for not just the immediate, but the 10, 20, 30, 40, 50 years, is obviously key.
Yes.
All right.
Yep.
Yeah, I was gonna say, if you
Yeah.
guys wanna go see a system, we could take you over to the Acton building. And you can walk around. If I recall correctly, we walked the front side of the building as it were, but we could walk the back end so you guys can see all the nuts and bolts, particularly you, Chris.
Okay, definitely.
I
Well, Keith needs to see it.
I'd like to see it.
I actually have a friend in Newburyport. I went to see his house for the first time. He's got a geothermal.
Does he?
I'd never seen one before.
What's he got? Probably one well, maybe two.
I'm sure it's just one. It was a very small house. And he just ended up with it, accidentally, I guess. Okay, I don't,
By the way, I used to work for RH White. In fact, I was on the horn with David White 2 weeks ago. If there's any information you guys need on the contracting side of that project, he's a resource. And it's just out there.
all right, I think public comment will be pretty easy because I don't see anyone there. So, any other business?
Oh, Katie's got her hand raised.
I'm just gonna ask,
Please,
Mark, sorry, this is a side thing. Mark, would you be available after this for a call?
Yes.
I sent you an invite. Okay,
Yes.
thank you. Just didn't want to lose you on this,
Yep.
before people hung up.
Okay, hearing no other business for this meeting, I'm gonna accept the motion for adjournment.
Second.
So moved.
All right, moved by Mark, seconded by Chris. Roll call, Mark,
Hi.
Chris,
Aye.
I vote aye, it's unanimous. It is 11:18 AM. I'm sorry we went over and thank you for hanging in with us and we'll see you next time.
Roger, one quick thing. I just want to
Yes.
compliment Kate for managing that presentation while the little one was behind. Very well done.
Very well done.
Brilliant.
Yesterday was the last day of school, so.
Yeah, well, that's
Yeah.
that was my next question. I thought that was executed beautifully. So thank you. And I hope the rest of the day is fun.
Well, I know that, I think Mark was juggling some, some childcare situation in that.
At
Well,
first, I
that-
thought it was Mark's granddaughter, but then I saw the little munchkin behind Kate, so
No,
I knew
I'm
we had
hiding
to.
in an upstairs closet. That's why I have to blur the background.
We're still recording, Mark. You don't want to say that out
That's all
loud.
right. When the kids are here, they're downstairs, but this is my first day off and I'm gonna say since September, so I'm happy.
Very good.
Sounds good.
Have a great weekend,
you all.
everyone.
Yeah,
Enjoy the
thanks.
weekend. See you all.
Sure, bye-bye.
Okay,
All right.
bye-bye.